In this video, I'm going to look at testing of Python code and how you can make it fun. You might be thinking that I can't be serious, but actually I am. Recently, I've convinced myself that Python testing can actually be fun and can help you enjoy programming more. And I'm hoping to convince you that next time you do some programming in Python, then you might want to consider doing some testing as well. So in this video, I'm going to be explaining about Python testing and about how you can incorporate that in your own code with some real working examples. This is aimed at the same people as my YouTube channel. It's about digital makers, people wanting to do some computer programming for controlling a electronic system, at hobbyist software programmers, perhaps you wanting to write some software and just do that for fun, and for students or those wanting to learn more about programming. And that's covers from school, high school, university, or if you're just looking to learn it because you enjoy learning things. What I'm not going to be covering is testing of critical systems. Some of the theories are still the same, and this will stand as a good foundation for that. But if you're wanting to create critical system software, then you need to go far beyond what this video is going to cover. But before you turn off thinking that formal testing of software code is boring, I'm hoping to prove otherwise. I don't normally test my code as such, and I think that's been a bit of a mistake. I've convinced myself that actually it's quite a good idea, and I'm hoping to do the same for you. Software testing is not something just for those creating life-threatening critical systems such as nuclear power stations and things like that. That actually testing should be part of your normal development process, and it can be fun. So why would you want to do testing? So these first two examples are obvious ones. If your system is important for life critical systems, perhaps the nuclear power station I mentioned earlier, or if you're creating fly-by-wire for an aeroplane, perhaps Boeing 737 MAX, or perhaps not a good example. But in those kind of systems, you better make sure that you're doing proper testing. The same if your company's reputation relies on it. Anyone for Windows Millennium Edition? That one didn't go down too well. But with proper testing, then you can make systems that are far more reliable. But I'm not going to talk about either of these. These are beyond the scope of what I'm talking about. I'm just talking about simple tests that you can make to make your software, your maker projects to run smoothly and make them more reliable and easier to program. So what testing am I going to cover? I'm going to talk briefly about test-driven development, but that's not my main focus. My main focus is really about putting in tests that are going to make your code easy to create, and so by doing so easy to debug, and that will hopefully make the coding process more enjoyable because it means you can spend more time doing the fun bits rather than spending time debugging. But also I'd like to cover that in itself it can be enjoyable and quite satisfying to go through the testing process. It's something you can actually enjoy and feel a great deal of satisfaction about, and that's fun. As I said, I don't currently do a lot of formal testing on my own code, but I've seen some real benefits when I have, and so perhaps it's something I'm going to look at doing more. But I do have a formal education in that. I recently, 3 years ago, completed a master's degree in computer science, and a lot of my study on that was around testing, test-driven development, and also about IT security, and a lot of that really comes down to how well the code is developed and tested in the first place. But this isn't just about the theory. I'm going to show you some practical things you can do using the Python unit test and how you can create very simple tests and help improve your code. So that'll be coming later on in the video once I've covered the theory. Test-driven development is one way of creating code. You start by creating tests before you even start any coding. These tests are things that you want the code to achieve. You then write the code to pass the tests. And you know that if you could pass those tests, then you're meeting that objective of the coding. Then you add more tests and add more code and keep repeating this cycle until you've met all the objectives and you've hopefully got some good code at the end, which you know has been tested to a good standard. This is a very structured way of programming, but it's actually quite satisfying. Each time you add new tests, you set yourself a target to achieve, and then you keep going until you reach that target. And for many gamers, you might know this feeling of satisfaction when you reach a target. It's a similar kind of thing when you're doing the programming. But although I've done some test-driven development, that's not really the main coding that I do. Usually, I start writing some code, I end up with quite a bit of code, and I find I've got bugs in it and it's not behaving in the way I expected it to or that I want it to. So then I think, well, let's do some more testing, particularly if you've got your code split across multiple modules. What you can do is you can test those modules separately, make sure they're behaving as you expect them, and then you know that the code that's going to rely on those doesn't have to test that they're functioning right. You know you can trust the data that's coming back, and therefore any problems should be in the main code you're looking at. It doesn't always work like that. Sometimes it's down to how you refine your tests, but at least it gives you a way of targeting your testing to the relevant parts. There is more theory I could cover, such as code coverage. How much of the code is actually tested by the tests? Data coverage. Have you covered all the different kinds of data that could come in? Looked at edge cases. Have you looked at certain values that may be at the extremes? And what does the code do in the event of a failure? Does it handle those gracefully or does it handle those appropriately? Then there's other things about how you could test your code further. Do you have to put hooks into your code so that the code behaves differently when it's being tested? That can have some pros and cons. It can test some scenarios which you wouldn't be able to emulate otherwise. But on the other hand, if you're changing the code, could you be not testing the code as well as it could? And you also need to think about how you generate your tests. So you're just going to create some manually, or do you have to create code that creates the test cases so that you know that you're getting a good coverage? All these are valid topics to consider, but really I'm wanting to move on to the practical side now. So there's some things you might want to research later, but now I'm going to move on to the practical. And really my theory in here is to try and keep the code testing simple. And if you're starting to get to the point where you're having to do all these, having to generate the testing code using more programs, then perhaps you're going a bit too far. Unless, like I say, you're on one of those scenarios where your testing has to be right, either from a commercial or life threatening point of view. So the practical example I'm going to look at is my Raspberry Pi LED matrix display, the code I created for that and the testing I had to do for that. So the code's actually split into two parts. One is a C program, and really the testing I've done on that has been through providing data directly into it. But I'm more interested in the Python program. The reason I felt testing was so important with this is because it uses a lot of date and time triggers, and trying to test those through purely creating examples in the code was time consuming and wasn't really testing or pinpointing the potential problems with my code. Once I started breaking those up into unit tests, I could make sure that I could put in examples of code, examples of tests that were specifically targeted at these edge cases, at the expected behavior, and make sure that was all working properly. And it actually made the coding much more enjoyable. And I'm going to show you some of this now. So here I am. This is the Raspberry Pi system that I'm using to test this, and these are the files. So as I said, there's 2 programs on here, but I've just extracted the one part of the program. This one's called Matrix Messages. What this does is looks at the time and date and this config file, and will generate another config file that's used by the Matrix Display Images program to display the images. So this doesn't display anything on the screen, it just runs as a daemon in the background, and it's constantly updating the config file that Display Images needs based on the time of day and the config file. So I'll just show you quickly around. I've got the code open in the Mu editor here, and you notice there's 2 files, which is the main part of the code. So this is the main bit of the code that runs, reads the config file. Mainly, most of the code is just interpreting that config file and making creating a message object. So the message class, so I've used object-oriented programming, put this into a separate class, and this is an entry for each of the entries in the configuration file, and this does most of the work. So the main code is about reading in the data, putting it into the messages, and then writing it out. And message.py has got the more important part, which is working out which code is valid, when it's valid, and how long to display each of the images for. And there's some special features of this, is that it's going to have to try and interpret different dates and different times, because it allows you to put a start time and an end time, and that start and end time could be on the same day. So you could say start at 9 AM and finish at 2 PM. But it could also say start time 2 PM, finish time 9 AM, in which case it needs to be interpreted the opposite. That means start in the afternoon and keep going all the way to the following morning. So there's quite a lot of code in to handle that, and that's the particular part that I wanted to test. I'll just show you the config file as well. It might give you a better idea of what we're talking about. So I'll leave this smaller actually. So I was developing this code around Halloween time. So I've used Halloween as an example in here, that in the few days prior to Halloween, I wanted it, so between the 1st and of October and Halloween itself, I wanted it to display a picture of a pumpkin effectively between 3 PM and 10 PM, and it used a PIR sensor, and there's a few other bits there. Then on Halloween day itself, I wanted it to run all day long. So I added this extra bit which says that it's going to start at 10:30 and run until 4 PM. And that will display the same images, but doesn't have the PIR part. PIR enable equals false. And then I've put a normal winter evening and one for the default, which is what it will call if none of the others are met. And this one starts on the 1st of January to the 31st of December. And the order is relevant. If it matches earlier, then that will be used. Otherwise, it keeps going down. So as you can imagine, there's quite a lot that can go wrong. And the main concern here was this message.py, this class file. And to make sure that this was handling everything correctly in the way it should, and interpreting start times, end times correctly, things like that. So I'm just going to create 2 tests for this. My actual test goes quite a bit further, but just to show you how to use the Python unit test. I'm just going to create a new file, and I'm just going to call it say testmessage.py. So this is going to be the tests for the message class. And the important thing is to import unit test. And this is the Python testing library that we're going to be using. Then of course we need to import anything that, well, the code that we're testing. So I'm going to import from message, which means the message.py file, import message, which is the main class in there, and then I'm going to include some date time functions because I'm going to need these for the testing. Then at the very bottom of the file I'm going to put effectively the main, call the main function. And if you've used Python with a separate main function in your code, you've done something similar like this before. But instead of calling my own main function, I'm going to call the main function for unit test. And the clever thing about that is that I don't need to create this main function, and this is going to find any functions within my tests or methods within my test and going to run them automatically. So it will automatically run all the tests that I create. So I just need to create the tests. So first I create a class. Just got the test message class. It doesn't matter what the name is, but the important thing is it has to extend the unit test case. And as long as it does that, then the methods in here will run. And then just create a function or a method. And again, it doesn't matter what you call it, as long as you make it unique. For every one of these, they all have to be unique, otherwise it'll only run one of them. And the job of this one is just to create a entry and see if it works. So this is the most basic test. If we're failing this one, then we're not going to get very far. So I'm just putting some dummy data in here, just some data that I'm going to use for the testing. I could put anything I wanted, as long as it's valid data for that function. And then I'm going to include what code I'd expect it to run. So it's going to run, I'm going to create a test message, which is an instance of the message class. And then that's all I need to do at this point, because I'm just doing a test of creating this class. So now I just need to put some tests in, and we use the assert methods for this. There's various ones, but the first one I'm going to use is assert equal. And this is going to see if two values are equal. And it's going to check that the test message title is equal to the title we've set it to. Very, very basic test, so it's going to make sure that this data that we pass to the message class is stored correctly in the message class, and that test message dot title is equal to this entry here. We could do the same for the directory, but to keep this simple, I'm just going to then show some other how we can test some of the functions in here, in the methods in the message class. So by doing a create, we've already tested the init function, not fully, but we've just tested that it's running. So there's various functions, methods rather, on here. But the three I'm going to test are these. The date valid checks if it's the date is valid for this particular time. Time valid, the time is valid, and date time valid is if the date and time are both valid. So I'm going to put those in as well, so that assert true is going to check that that this test gives a true result. So that should say date valid. And then because we've only put very basic here, these should all pass. So it should be true. Let me check time valid. And then we're going to check the date time valid as well. So if we save that and run that, what this is going to do, it's going to run all these tests, and only if all these are correct will this test pass. Nope. Oh, sorry, no. Sorry, shouldn't be. It should be import. Ran one test. So that actually shows that the test ran okay, but then the exit, system exit false. So I think actually that's fine. It's just the mu editor shows the system exit, which is causing a bit of confusion. We'll try running this on the command line instead. So the file's in here called test_message. I've not given it execute permission or anything, so I'm going to go with Python 3 test message, and there we go. That's better. So as you see, this does actually match all the results for this. So you can just ignore that traceback if you're doing this in the mu editor. What it's saying is each time there's a test, it will put a dot there if it passes. If not, then if it fails, it'll put an F instead. So it says it's run one test and it took 0.001 seconds, and the tests are all okay. So I'm going to now add a second test to show you how you'd add a second test. I'm going to put a couple of different things in here, and rather than watching me type, I'm actually going to copy this from the actual test that I've created. So this one is a method called test start now, and it's going to look at the date now and use that for part of the tests, and going to give the data based on the current time, and current time minus 2 minutes, and end time is going to be in plus 2 minutes, so it's going to mean this is a valid time. Creates the test message instance as before, checks the title, the directory, and these are all the tests we've done so far. And then it's going to also do an assert equal, so it's going to test one of the other methods that's in that function, which is messages to start, and make sure that responds with 0, because it should be already started, or there's no time before it needs to start. It can start now. And then there's another one that sometimes in your tests you can't guarantee exactly what the result's going to be, because it depends on when it's run. Because although we've set 2 minutes, if it takes more than a few seconds to run, then it might be only 1.9 minutes and it'll return just 1 minute instead of 2. So this one can check it's also almost equals, checks this value. The value should be 2, but if it's got a delta of 1, which means it's can have 1 less or 1 or more, then it will still pass that test. And I'll run it on the command line again. And as you can see, ran 2 tests and all okay. And notice there's 2 dots there. That means each time there's a test run, it gets a dot. So those are both passed. But if I intentionally make this one fail, so as well as assert true, you can put assert false. This is going to be true, so this will fail. Make sure I save it first. And as we can see here, so this is what failure looks like. The first test ran okay, so there's a dot there. The second didn't, it's failed, so it's given a big F there. Fail told you the test that failed, which was test start now. Line 34, which is this one, a certain error got back from the programmer true, but we were expecting it to be false. And it says ran 2 tests, failed, failures equals 1. So this is where I come from, is when you're creating multiple tests, what you do, you wouldn't just take 1 or 2 tests, you might create half a dozen tests, and you might find it instantly that one of them passes, the rest all need a bit of work. And then as you go in, you change your code. It might involve tweaking your tests if you've done your testing correctly. More often than not, it involves tweaking some part of that code in your message class to make sure that gives the right value, and then rerunning the test once it's fixed, and a satisfied feeling that you've passed all your tests. Now, just having these 2 tests isn't really going to test much. It's about creating lots of tests, or really depends on how thorough you need to be and how many different edge cases you can think of and things like that, how many tests you create. But once you've created them, the important thing is that every time you make some change to that code, even if you don't think it's related to any of this, rerun those tests. It will then identify if the changes you've been making from that code have broken anything that was working before. And this is a really powerful and really useful tool, and I do recommend that you use this. And now one more thing I like to do is that I like to keep my code separate to my tests. So I like to create a separate folder directory called tests and move my test functions to that folder. However, this has got a problem. So if you remember back to that code that we were using, it uses the message class. So if I try and run it from a different directory, it's not going to be able to find that message class. So I display that again. So if I do run the test message.py, no module named message. So the way I like to overcome this is you just put a single file which would go inside the same folder as your main code. And I'm going to call this run tests. So it does mean having a file inside the main directory, but other than that, everything else will then go in the tests directory. And this really just needs to call the file in the other directory. I'm going to use a hashbang line to allow it to run directly, and then I'm going to import unit test, import from the test directory the test message class that I created, import everything from there, and then that same call to the main of unit tests. And what this is doing, so it's importing the unit test as we did before, but then importing from the tests directory the test message class that we created, import all the everything from that test message class, and then when it's run, which is if you are running this as an executable or from the Python interpreter, it will run this. If you're importing it, then it doesn't, and it's going to run unit test.main. If I save that, change back to there, and I can give it executable permissions, and then literally all I need to do is run tests. Yep. So that should say if, not from. It's better. And then it's going to run all those tests. And now all I need to do, I only need to create this once and import any tests. And if I wanted to create multiple tests for different modules, I can put them all in here and it will test them all together. I can still call them individually if I wanted to, but this way I could just, every time I make a change, before I commit it to GitHub or to whatever I'm using, just call run tests, and then I know it's passing all my tests before I upload the code. So if I just load the tests to show you what I've created again. So the tests I've created here are quite basic. The amount of code they cover in terms of code coverage is not all the code, although there is a good chunk of that code, because that init function, init method, so all this will be run. There's a few potential break points or return points, but pretty much all this code is going to be run. But for instance, if this bit will only be run on the first test because its start date has not been set and the end date has not been set, but won't be run on the second one. So this is what I mean by code coverage. You need to look at, are you running the code that's inside this if statement? And then you also need to look at, am I testing all the relevant methods? There's minutes to end, but there's also minutes to start. I've only tested one of those, I think. Actually, on this one I tested both. On the first one I didn't test any. So actually I have tested both those. So the other thing I want to think about is about whether you include testing hooks within your code and what that means. I haven't done any at the moment. However, this is something I am thinking about adding to my testing for this. The reason being is that when I run tests on here, they're all time based or date based, and it means that I can only put in tests that are based around the current time, because the message.py makes constant reference to the current time, which is the datetime.now. So if I want a test to pass, I have to take into factor the current time, and that limits the tests I can run. I can't run a test 1 second before midnight and see if it still handles it correctly, or I can't run a test over a change in month or a change in year and make sure it tests correctly. So I'm limited to what I can test without adding any form of hooks in. So for instance, if I wanted to override this now, then what I could put in is I could put in a separate argument that's optional, and then if that argument's there, then instead of using today.datetime.now, it would instead use a time that I set within the test message class, and it would allow me to do that. So that's something you might want to consider. And then the other thing you might want to consider is whether you want to generate these tests automatically, because they're not particularly difficult to create, but there's only so much you want to do by typing manually. So if you wanted to be able to test certain increments, if you want to be able to test different months throughout the year, then you might want to be able to use some code that would generate this test message for you automatically. So there are just a few things to consider. They're not included in the code so far, but it is something that I'm definitely thinking about for future, so that I can be more comprehensive with my testing. But as a maker, it's a tie-up between how long do I spend creating my tests and testing it versus how long do I spend coding it and things like that. And there's a balance to get, and it's really down to you how much you feel comfortable testing. And remember, I'm saying testing should be fun. You don't want to get to the point where you just feel like you're being controlled by your tests. Let yourself get that balance. So hopefully you found that useful, and you're going to consider introducing testing into your code when you're creating it. And I hope the unit test examples shown are helpful in that, and I've got some links in the description if you want to find out some more information about that. So if you haven't already subscribed, then please subscribe to my channel. You'll find other hints and tips about programming and maker activities, and I hope to see you again on a future video. Thanks for watching.